Welcome to ZaranTech. This video on Snowflake Database Architecture. I'll be walking you through the key concepts and components of Snowflake's unique architecture. Snowflake is a cloud data warehouse that has gained immense popularity due to its flexibility, scalability and ease of use. Let's start with a quick disclaimer. The materials in this video are provided for informational purposes only. It's your responsibility to comply with copyright laws. No part of this document may be reproduced without permission, except for fair use. Images from open sources are used for illustration only and cannot be used for promotional purposes without consent. In this video, we will focus on understanding Snowflake's architecture and how it provides these advantages. Snowflake is a cloud-based data warehouse solution provided as software as a service. It fully supports standard SQL for querying data. The unique architecture of Snowflake reduces the administrative overhead and enables users to easily create tables and start analyzing data with minimal setup. Some of the key features and advantages of Snowflake include: near zero administration. Snowflake takes care of all the maintenance, optimization and infrastructure management. Users don't have to worry about these tasks. High availability. With data replicated across multiple availability zones in the cloud, Snowflake provides very high uptime. Security. Data is encrypted both at rest and in transit. Granular access controls and network policies provide secure data access. Sharing and collaboration. Snowflake allows easy and governed sharing of data across accounts and organizations. Multi-cloud. Snowflake is deployed across multiple public clouds like AWS, Azure and GCP. This prevents vendor lock-in. Performance and scalability. Separate storage and compute allow independent scaling. Workloads can be scaled up and down. Pay-as-you-go pricing. Users only pay for storage and compute resources used. No upfront costs. Snowflake uses a unique hybrid architecture that combines the best elements of traditional shared disk and shared nothing architectures. Let's look at both these traditional architectures first. In shared disk architecture, used by traditional databases, there is a single storage layer accessible by all cluster nodes. The nodes have CPU and memory but no local disk storage. They leverage the centralized storage for data processing. In contrast, shared nothing architecture distributes data across storage on cluster nodes along with CPU and memory. This allows partitioning data across the nodes. Snowflake uses a hybrid model with three distinct layers: storage, compute and cloud services. The storage layer acts as a shared disk. The compute layer provides virtual warehouses for executing queries similar to a shared nothing architecture. The cloud services layer handles security, metadata and other coordination. The storage layer in Snowflake organizes data into micro-partitions. Data is stored in columnar format in cloud storage. This acts as a shared disk available to all compute nodes. Users don't have to worry about data distribution. Storage can scale elastically and is charged for average monthly usage per terabyte. The compute layer consists of virtual warehouses, which are MPP compute clusters provisioned on demand in the cloud. Virtual warehouses provide the query processing power and can be scaled up and down independently of the storage layer. Virtual warehouses provide many advantages. They can be started, stopped or scaled at any time without affecting running queries. They can also auto-suspend after an idle period and auto-resume when queries are submitted. Virtual warehouses support auto-scaling based on load. Some of the advantages of virtual warehouse are listed below. Virtual warehouses can be started or stopped at any time and also can be scaled at any time without impacting queries that are running. They also can be set to auto-suspend or auto-resume so that warehouses are suspended after a specific period of inactive time and then when a query is submitted are resumed. The cloud services layer handles security, access control, metadata management and query optimization. It coordinates across Snowflake components. These three layers scale independently and Snowflake charges for storage and virtual warehouse separately. Services layer is handled within compute nodes provisioned, and hence not charged. This slide summarizes the comparison between shared disk and shared nothing architectures and how Snowflake gets the best of both. Snowflake provides many options to bring data into its architecture through loading and integration. These include user interfaces, command line tools, drivers, connectors and third-party ETL or BI tools. The focus on accessibility helps Snowflake be widely adopted across organizations and teams. That covers a high-level overview of Snowflake's unique and powerful architecture. Let me know if you have any other questions. I hope you found this presentation useful. Thank you for your time. Please leave your feedback after the session.